when we're looking at an atom, guys, what does the atomic number tell us? This is a review. Number of protons, right? Is that unique to every element, or is it the same for every element?
It's unique.
Yeah, it's unique. That's the thing that identifies the atom, or what element that we actually have. All right, if you change the number of protons, you change the what? The element. Okay, that's one thing to remember. So when you're counting protons, neutrons, and electrons, so we've got a quiz on Thursday where you guys will be doing this. We're going to finish it up here today and practice it today and tomorrow some. If you change protons, the number of those, you change the element. So remember that. It's the first thing. It's the easiest thing. It's what you should identify first, and then everything else starts to fall into place from there. Number of neutrons. How do we figure out the number of neutrons? This we had to do a little bit of calculating. Alex.
You subtract the atomic number from the atomic mass.
Okay, so he said you subtract the atomic number from the atomic mass. Now, one thing I just want to point out, guys, it's not called atomic mass. Okay, look in your notes. What did we call that number there yesterday? And we'll talk more about the difference between the two later in the week. And your lab today is going to start getting you to see that difference. But what did we call that thing? It was symbolized with the letter A. The mass number. All right, so it's mass number minus atomic number. Okay, that's what gives us the number of neutrons. So guys, the big thing, mass number is a whole number. Can we have part of a proton or a neutron? No. Okay, that's why it's a whole number. So atomic mass is exactly what you thought. We looked at the periodic table yesterday. Get your reference packets out. You're going to want to have those. Okay. But that atomic number is that decimal. We're going to learn today in lab why there's a decimal versus the mass number that's a whole number. Okay, so I want to point out, it's a key term difference there. They're not the same thing. Okay, so be careful about calling it atomic mass. All right, but that's what we reviewed yesterday. We started doing a little bit of practice. We're going to continue with that here today. There was one other thing that we talked about, and that's the number of electrons. How do we figure out the number of electrons? Grant? Yeah, they equal the number of protons when? Not exactly. It doesn't have a charge, and that's what you meant, an ion, right? When it's neutral, guys, all right, that's the big thing you want to jot down. Remember, when it is neutral, that's when electrons equal protons. Today, we're going to get into those things called ions that have charges. All right, that's one thing we're going to talk about here today. So that's a brief recap from what we talked about yesterday. I know we kind of went through things quickly, went through the atomic timeline. I believe that everybody in here sent me theirs. If you have not, you need to get me that PowerPoint today. Okay, you have got to send that to me today. I believe that did I collect everybody's? I think I did. I'll check in lab. We can talk about that if I don't have it. All right, so take a look. You don't have this in your notes. Okay, we're going to kind of talk through it together. We've got atom 1 over here on the left. We've got atom 2 on the right. Number of protons. How do you think how am I going to identify protons here in these pictures? They're going to have a what? Yeah, the one with the plus. So, in atom 1, how many protons do I have?
5.
I've got 5 protons. Okay, how many neutrons do I have?
6.
I've got 6. Then what's my mass number then?
1.
No. They each have a mass of 1, but how do we get the mass number of the atom?
11.
It's going to be 11. How'd you get that, Alex?
You added
Yeah, you're going to add the protons and neutrons together, and that gives us our mass number. And again, notice, it's not a decimal because you're not going to have part of a proton or part of a neutron. Take a look at atom number 2. Count up and see how many protons we have. What's that? 9. How many neutrons? What's our mass number going to be? 16. So who can tell me what element is atom number 1? Abby?
Boron.
How'd you figure out that it's boron?
Because the number of protons is the atomic number.
Absolutely. If you have the number of protons, guys, you have what the element is. You just have to look it up. So that's boron. Atom number 2 is going to be what? Fluorine. Now, take a look at those masses that are there. Okay, so if we take a look at boron, what's the atomic mass that you see on the periodic table, on your table? What's that number? 1, we know it's a decimal, but what is it? 10.81. Is 11 close to 10.81? Absolutely, right? but it's not the exact same, so we'll talk about why there's decimals. But take a look there at fluorine. What's the atomic mass of fluorine? 18.9. It's almost 19, right? Is ours 19 up here? No, it's 16. So obviously there's something else. But is this still fluorine even though the mass is a little off? Yeah, what makes it fluorine? The number of protons. So we can see, guys, that the masses may be different than what we see on the periodic table. Why do you think that might be? Why do you think, given what we're just talking about a little bit, make a hypothesis, make a guess as to why those masses have decimals and why they might be a little bit off of what we're seeing here? Any idea, Tony?
Because it's probably an average.
It's an average. Absolutely, guys. The atomic mass is an average. It's an average of something. All right? Does anybody know what those somethings are that it's an average of? Let's take a look and see. Isotopes, guys. It's an average of all the isotopes. Take a look here. This is a strip of, like it's a picture of magnesium ribbon. You guys, have you guys ever seen magnesium ribbon before? You will. Friday, the storage room's getting all cleaned out and stuff. So after that, I'll go in there. We'll do a couple different experiments with magnesium ribbon. You guys are going to have to see one cool thing that it does later on this year. But take a look. So this is a cross section of magnesium ribbon. Okay. Take a look here. Are all those atoms the same? Take a look at the picture that's up there. Are they all the same? No. What's different about them? The number, right? Now, anybody have any idea as to what this numbers, all these numbers, mean? This is a specific way, a specific notation that we use to write atoms and isotopes. This is what we call isotope notation here, guys. Take a look at your periodic table. Look at those numbers. We have 24, we have 25, we have 26. Do you see anywhere on your periodic table what those numbers might represent? What are they close to? Given the information you have on your periodic table with magnesium, are they their atomic numbers? Is that the atomic number of magnesium? No. What are those numbers close to? The mass. Those are the mass numbers, guys. They're telling you the mass of those atoms. All right. So what an isotope is, it's when we have atoms of the same element, okay, with a different number of neutrons. This leads to the element having a different mass. Okay? So make sure you fill that in your notes. All right? Atoms of the same element with a different number of neutrons, which leads to the element having a different mass. Something huge. So that number, guys, that you see, that atomic mass on the periodic table, it's the average of all of the isotopes. All the different naturally occurring isotopes. If we take a look back here at this picture, okay, there were a lot of what? What was the most isotope that we saw here? 24, right? There's way more 24s than there are 20. I see 125 here, and that might be it. And I see a 26 here and a 26 here. What is the atomic mass of magnesium when you look at your periodic table?
24.305.
24. Does that make sense? That, hey, it's closer to the 24. Look how many more 24s we have than 25s and 26s. So this is not just an average, guys. It's a weighted average. Okay, when we talk about average atomic mass, which we'll get into that definition a little bit later on, it's a weighted average. Do you guys know anywhere else in life where you might have a weighted average? School, right? Your grade in this class is a weighted average. So that's what we're going to get into more next period in lab. All right, but big idea, big definition, same element, different number of neutrons. That's the key. An isotope is a different number of neutrons, therefore it has a different mass. Protons, did they change? No, because what happens if we change the number of protons? You change the element, absolutely. So there's two ways that we can write our isotope notation. Okay, we have this thing called hyphen notation, and this is the one, I'll be honest, that most of my students forget by the end of the year. That's okay, we'll come back and review it, and you'll remember, oh yeah. So it can be written in two ways, and I believe you guys have some symbols there. You're going to want to jot those down as we go along. So hyphen notation, it can be written something like this. You can either have the whole element written out with a dash that says like 235. Okay, so this is our element. and then this is our mass number. So when they write out a hyphen notation or symbol notation, we'll get to in a second, the number that they give you in hyphen notation, it's giving you the mass number. Okay? It's not giving you protons, it's not giving you electrons, it's giving you the mass number. From that, you can calculate everything else. That's one way you could see it, or you could see it like this, where it's just the atomic symbol with that dash or that hyphen, and same thing. This is still the mass number that's listed there. They are the same thing. Again, this is the one that people will tend to forget more often than not, because it's not one that we use as much, but you will see it. I'll throw it in there every now and then. People will be like, what's that? So make a mental note of it. The much more common one is what we call symbol notation, and that looks something like this, where we use the symbol, and then up here we have the mass number. So this would be our mass number. Down here, okay, down here we have something else. Maybe you guys have seen this before. 8th grade, you guys do anything like this? Nothing? Okay. Maybe, maybe not. That's okay. What do you think that 92 is? That's our atomic number. And you're going to see this a lot. Okay, you're going to see this symbol notation a whole lot throughout the year. This is the much more common way. And there's another thing we're going to add to it, but we'll get there in a few minutes. Do you think we have to have this atomic number written here in the bottom left corner? Do you think that has to be given to you? Why not? Why don't you need it? Yeah, exactly. If you had the symbol, guys, you know, and you can easily identify the atomic number because you can just go to your periodic table and look for that symbol. Which, again, goes back to why you had to memorize certain elements in our last unit so that you guys can go there very quickly and know where they are. All right. So both of these two notations, they're going to tell you the mass number. From this information, you can then figure out protons, neutrons, and electrons just by giving either of those notations. Okay? So that's an isotope. There's another I term. Question. Grab a pass and go really quick. Okay? Everybody good here? Can I go on? All right. Here's an example. So uranium-235. You guys can go through. Tell me protons, neutrons, and electrons. I'll give you a couple seconds to try it. Who can tell me the number of protons in uranium-235? Just shout it out. 92, right? Atomic number. What's the next easiest one to identify, guys, for this problem? Electrons. How many do we have?
92.
How do we know it's 92? Because it's a what type of atom? It's neutral. Okay, we'll talk about how we identify if it's neutral or not later in just a couple minutes. So how many neutrons do we have? 143. How'd you get that, Grant? Exactly. You take your mass. You're going to subtract out the number of protons. And that's how you're going to get your number of neutrons. Okay, you got to do a subtraction problem. All right, same thing. Nitrogen 15. How many protons do we have? Just shout it out. 7. How many electrons? We need the same. It's neutral. How many neutrons? 8. So again, we got that. We took 15. We subtracted 7. That gave us our 8 for our number of neutrons. Easy? All right, it should be. I hope that it is. Okay, if you're struggling, guys, ask questions. All right, so there's one I term. We're talking about the atomic structure. There's another one. And this is where we're going to be able to identify, is it a neutral atom or is it not? What's that term called? Isotope we just had. The other I term is an ion, guys. So how they differ? What do you think is going to change with ions? The number, we've already talked about protons can't. The number of electrons is what's going to change. Absolutely. So guys, they are atoms of the same element with a different number of electrons. The different number of electrons leads to them having a different charge. Okay? The charge occurs from either gaining or losing electrons, not protons. That's something you probably want to highlight or star in your notes. It's not the number of protons, because what happens if we change protons? You change them. I'm going to ask that question, guys, over and over to drive that home. Okay? If you change protons, you change the element. Yeah, the charge might change, but you've already changed the element, and therefore it's incorrect. So when you have a charge, okay, you have a different number of electrons, and that's the key, different number of electrons. I'll come back to this in just a second if you need it. So going back here to our symbol notation, where you might see a charge, guys, is somewhere up here. Anywhere on the right side, upper right corner, that's your charge. Okay? Add that to your symbol notation. If you see a charge, it could be a plus or a minus charge in the upper right corner, that's how you know you have a charge. It's not new. If there's nothing there, what is the charge? It's what? It's neutral. It's 0. There's no charge if there's nothing written there. Hyphen notation, it does not tell you if it's neutral. If you see hyphen notation, guys, you're assuming that it's neutral. Okay? Because it's not having a charge written there. Charge will only be there in symbol notation, not in hyphen notation. Okay? So, ions. We have two types of ions. We have cations and we have anions. Cations, guys, they have a positive charge because they lose electrons. Positive charge, lose electrons. When we go back and do redox chemistry toward the end of the year, oxidation reduction, we'll come back and talk about this process that's happening. Okay? How I remember cations is if you look right there in the middle, you have a T. What does that T look like? A plus sign. In the word, there's a plus sign. That's telling you guys it's the positive one. That's how I remember it. Find a way for you to remember the difference between the two, because you've got to know the difference. Anions, they have a negative charge because they gain electrons. What's the charge on an electron, guys? We talked about it yesterday. It's negative, right? So if you gain negative charges, you're going to have, if you gain electrons, you're going to have a negative charge. If you lose negative charges, you're going to be more positive, therefore you should have a positive charge. Anion, in that middle there, it's got an extra N. That's how I remember it's a negative charge. Again, you need to find some way that works for you to remember the difference between the two. Question?
So are the charge of humans negative or positive?
What's that?
What atoms are we made of?
We're made up of lots of different atoms, like carbon and oxygen and different things. When you have... Alright, so those are our two types. Here's the rule, guys, to count when you're counting ions. It's pretty much the same as before. Protons are the atomic number. Neutrons, we're taking the mass number minus the number of protons. Here's the one that changes. Okay? With electrons, there's a couple ways you can kind of think about it. Protons, you're going to subtract the charge. If you always subtract the charge, alright, it's going to get you the right answer. So, for example, let's say we have something like, well, we'll do an example in a second. When you subtract a negative, guys, what does that really become?
Positive.
A positive. So if you think about it like this, if you have a positive charge, you're going to subtract that from the number of protons. If you have a negative charge, you're going to end up adding it. You're going to do the opposite of what the sign says. You'll see what I mean as you go through here. Let's do an example. Ba. What is Ba? Barium. So barium 2+. What's the first thing we should do? Which is the first one we should get? Always. Protons. How many protons does barium have? 56. Look on your periodic table for that. Now it's up to you. Do you see a mass number given to us here? Is it up here in the upper left-hand corner? You see a mass number? Do you see a hyphen notation? No. So if you don't see either of those, okay, if you don't see either given, guys, that's when you're going to round the atomic mass to the nearest whole number. So if we look at barium, what's the atomic mass of barium? 137.3. So when you round that, what is that going to round to? 137. How do we figure out the number of neutrons? Subtract out the number of protons. When you do that math, what do you end up with? 81 neutrons. Okay? Nothing has changed yet. Protons still the same way. It's the atomic number. Neutrons. Take your mass number, subtract out your number of protons, gives you the number of neutrons. Electrons is the new piece, guys. So if we take a look over here, if we take our number of protons and we subtract the charge, we're always going to get the right answer. So we have 56. What's our charge here? Positive 2. So we're going to subtract out a positive 2. What's that going to give us for the number of electrons? 54. Think to yourself, does my answer make sense? I've got a positive charge. So of my subatomic particles, which subatomic particle is positive? Protons. Which is negative? Electrons. Which should I have more of, guys? If I have an overall positive charge here, which of these two should I have more of? Protons. Do I? How many more do I have? There's my charge. Does that make sense? You guys go ahead and try Chlorine minus 1. Who thinks they can tell me how many protons does chlorine minus 1 have?
17.
17. Okay. Neutrons?
18.
18. How did we get that?
Gotta subtract the atomic.
Right. What was the mass number that you had?
35.
Right, 35 because you rounded it because it did not give you a mass number anywhere. Okay. Then we subtracted out our protons. That gave us 18. Now electrons. How many electrons do we have?
19.
So we have a minus 1. So we take our number of protons, 17, minus a negative 1. When we subtract the negative 1, what are we really doing? Adding 1. So we should have 18. Questions? So now what we're going to do is we're going to practice this, folks. This is what your quiz is on Thursday. Protons, neutrons, and electrons. Okay? It's going to look something kind of like this. And this is what I had to load in. This page in your notes, I believe it's the next page, page 4. Take a look, guys, right here. You have a reference chart, a reference diagram that shows you not only what symbol notation means, it shows you that, hey, your mass number is up here, your atomic number is down here, your charge right here. It tells you how to calculate your neutrons. It shows you how you got those different pieces. Use this as a resource. Okay, this is a great resource to look back at, especially later on toward the end of the year for review. So let's do the first one here together. All right, atomic number is going to be the easiest one. For hydrogen, what's our atomic number? 1. What's the atomic mass of hydrogen? 1.00794. It's the decimal, guys. Remember, maybe you want to jot this down. Atomic mass is the decimal. Now, mass number. Do they give us a mass number in our element/ion, that first column? No, they don't. So what are we going to do to get our mass number? We're going to... We don't have to look it up. We're going to round, okay? If they don't give it to us, we're going to round. So when we round that atomic mass, what is it going to be? 1. How many protons does hydrogen have? 1. How many neutrons? Here, look at this. This chart is set up like this. We take our mass number, subtract out our protons. That gives us our neutrons. How many neutrons will we have? 0. How many electrons? How do we know it's 1? Because what type of atom is this? This is a neutral atom. Let's take a look at the second one. We have H+. Is the atomic number going to change?
No.
Is the atomic mass going to change?
No.
Remember, those electrons, guys, do not have any impact on our mass. Is the mass number going to change then? No. Is protons going to change? No. So 1 minus 1 is going to give me 0. Now, electrons. Will the electrons change? Why? Because I have a positive charge. Now, positive charge, what am I going to have to do to that? Subtract. So 1 minus 1 gives me? Take a look, guys. This is something that's very, very important to us that we'll talk throughout the year. An H+ ion, the hydrogen ion, is very, very unique because what is it? It's only a what? Anybody see it? It's only a proton. That is something that really comes into play when we talk about acid-base chemistry later on in the year. All right, so just as a little side note there. All right, the next one, this is the last one we're going to do together. Atomic number is what? 6. Atomic mass is? Remember, guys, atomic mass, you go right to the periodic table, and you jot down what you see from your table. Mass number. Does it give me a mass number here? What is the mass number? 12. It's not that we rounded this. Okay, so I want to point this out, guys. We didn't get that 12 mass number from rounding. It just happens to be what we would have gotten from rounding. But this upper left corner, that's where we figured out and we looked to get our mass number. It happened to be the same this time, but it may not be that way all the time. How many protons do we have?
6.
How many neutrons will we have?
6.
How many electrons? How do we know it's going to be 6? No charge. It's neutral. You guys are going to go through and work the rest of these problems on this page. All right? Go ahead and get working with it.